Now we're going to start looking at numbers and what they do to a graph when they are added into an original function. So in order to explain this, I'm going to deal with y equals the absolute value of x. So the function in this case are those two vertical lines, and absolute value just means we don't care about direction. It takes away the idea of sign. It asks us how far away from 0 is a number. So the absolute value of 4 would just be 4 because 4 is 4 steps away from 0. Similarly, the absolute value of -4 is 4. So in some of your examples, the function you're going to be applying is x squared, or squaring it, or the square root of x. So you root the x. The function that we're going to be applying for the examples is take the absolute value. So the first thing I'm going to do is get a graph of this original by making a table of values. And when I do a table of values, I pick the x's. Never a bad idea to kind of start with -3, -2, -1, 0, 1, 2, 3. Sometimes that doesn't give you enough information, but it's a good starting place. So now to find the y, the function I'm going to apply is I'm going to take the absolute value of x. So the absolute value of -3 is just 3. It's 3 steps away from 0. The absolute value of -2 is 2. -1 is 1. 0 is 0. 1, 2, 3. So the absolute value doesn't do anything to a positive. I'm going to go to my graph and I'm going to get these graphed. And I'm going to use a scale of just 1. So everything is counting by ones. Now I'm pretty familiar with the absolute value graph, so I don't need to look at the table of values, but -3 went with 3. This is right from our table of values. -2 went with 2, -1 went with 1, 0 went with 0, 1, 1, 2, 2, 3, 3. And those were just the numbers out of our table of values. The absolute value is actually a V. If I could draw straight lines, these would be straight. Teach you a little trick I teach my students. If you miss a dot, make the dot a little bit bigger so it touches, but that is the basic or the original function. Y is the absolute value of x. If I go back to our questions, they want us to describe the translation, and I'm actually going to grab a different color pen because I'm going to do each one in a different color. So the first one is x minus 2. The important thing is that this x minus 2 is inside the function. So that numbers inside are horizontal translation. A translation is just of movement. And if it's part or inside, it's left or right, and it's the opposite. So because this is subtract 2, or it looks like left 2, this is actually going to take the original and move it right 2. If it's at the end, it's up or down, and it's the same. What you see is what you get, and I'll talk about that in a second. But this just moves each point right 2. There's the describe the translation. So now if I go to my graph, I'm going to take each dot, keep it at the same height, and just move it right 2 spaces. So the effect of a number inside the function moves it left or right, and it's the opposite of what the sign is. So now when I see x plus 1, that's going to move it left 1. It's inside the absolute value, so it's part of the function, and I do the opposite. Now it's important to always go back to the original. So I'm going to go back to the original, which is the absolute value of x, and to apply the plus 1, I'm going to take each of those original points and just move them left 1. So the effect on the graph is each point just moves to the left 1. I think I'm getting worse at hitting my points. And we are definitely going to be labeling our graphs since we're getting so many on the same axes. Now I have a number at the end, so that is not inside or part of the absolute value. So now that becomes a vertical or up and down move because it's at the end, and it's the same. So plus 2 just literally means I'm going to take each point and move it up 2. So back to my original, because I'm doing the absolute value of x, which is the blue graph, plus 2. You can see where the different colors comes in handy. So that is the original graph moved up to the original absolute value plus 2. So we have one more to look at, which is subtract 3. So because it's at the end, there's nothing magical about it. It's down 3. I apologize for the yellow. I'm running out of colors. But now I'm going to go back to the original and just take each spot in, each point, and move it down 3. And again, I just kind of cheated and I knew where those were going to end up. So that's how you apply numbers that are being added or subtracted inside or at the end. For this next example, I couldn't get my equations to transfer nicely over to my notebook software, so I just wrote them in. So the graph we're going to start with is y equals 1 over x. So again, I'm going to make a table of values. Now on the assignment, it uses the square root of x, which means you won't do negatives. You'll start at 0 because you can't square root negative numbers. So I'm going to do 1 divided by the x. So 1 divided by negative 3 is negative 0.33, or negative 1/3. 1 divided by negative 2 is negative 0.5. 1 divided by negative 1 is negative 1. 1 divided by 0 is undefined. It doesn't work, and I'll talk about that in a second. 1 divided by 1 is 1. 1 divided by 2 is 0.5. And 1 divided by 3 is 0.3. So if I go to my graph, I'm going to still use a scale of 1 because I'm going to be moving it, and it's actually just easier to move if everything is 1. My y-axis, my x-axis. So negative 3 was negative 1/3. Negative 2 was negative 0.5. Negative 1 was negative 1. And actually, if you open up graphing software on the computer, if you Google it and look at it, you'll get that kind of graph. Now, at y equal to 0, we have what's called an asymptote. It's a dotted line. It's hard to see because it's right on the axis, but it says that we can't have any of this value. Now, 1 went with 1, 2 went with 0.5, and 3 was 0.3. And again, I'm going to kind of get this shape. I'm going to take a minute to talk about domain and range just for this one, just to kind of review what's been going on. So in this case, the domain would be x can't be 0. That means everything but 0. The graph is going to go all the way to the left. The graph will go all the way to the right, but there's no value at 0. Same thing for y. Y goes all the way up, y goes all the way down, but you'll never be able to get to 0 because there's no number that you can divide into 1 and get 0 as an answer. So now they want us to say to graph 1 over x plus 1. Now the function in this case is 1 over. So this is part of the function or inside the function, even though there's no brackets there. So this is left 1. Remember, inside is opposite of what you have. So I'm going to grab a different color, go back to my full screen, go to my graph, and everything's going to move left 1. So all the points stay at the same height. They just move left 1. And I'll talk about the asymptote in a second. So the asymptote was this dotted line at 0. It is also going to move left 1, which is kind of nice because we can see it now. And this is what my graph ends up looking like. So y equals 1 over x plus 1. I forgot to graph my original. Pretend this is in blue. That's 1 over x. Now they have a minus 2. The minus 2 is at the end. It's not part of the 1 over. It's outside it. So it's vertical, and what you see is what you get. So I'm going to go back to the original and move everything down 2. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, and 1, 2. The asymptote stays at the y-axis, or x equal to 0 in this case, because we haven't moved it left or right. So y equals 1 over x minus 2. Now for the last one, we have, I went the wrong way, two numbers. We have a subtract 4 inside the function. So this is part of the 1 over, so that's going to mean right 4, and then that's at the end, so it's going to mean up 1. So I could do it in 2 steps. I could move everything right 4, draw a graph, then move everything up 1, but I'm just going to take each point and apply that to it. So I'm going to go to this point and I'm going to go right 4, 1, 2, 3, 4, up 1. And you can see where having the colors helps keep things straight. Right 4, 1, 2, 3, 4, up 1. Right 4, 1, 2, 3, 4, up 1. Okay, the asymptote is going to go right 4, 1, 2, 3, 4, but I actually don't have to move it up or down at all because it goes all the way. It doesn't have a height. I have to do these points now. Right 4, 1, 2, 3, 4, up 1. Go back to this one. Right 4, 1, 2, 3, 4, up 1. And then this final blue point, 1, 2, 3, 4. And if you ever feel like your graph is getting too muddled up, you absolutely can make a new one. But that last one is y equals 1 over x minus 4 plus 1. Opposite, same.